We'll begin our discussion on estimating a population proportion by first discussing what is a proportion. So a proportion can be given to you as both a fraction, or a decimal, or a percent, and they're used to represent a portion of the total group. And in this section, we want to use a sample to estimate a population proportion. So here are some key terms that we want to be able to use. First, what it means to be a point estimate. Now here your formal definition of a point estimate is that it's going to be a singular value that we're going to use to estimate the population parameter. And in this case, our parameter is a proportion. So again, parameters can be either a proportion, a mean, or a standard deviation. And right now we're going to be talking about a population proportion. And this point estimate is the most consistent estimator of P. And this P, what it is it's actually called rho. It's a Greek letter that stands for the population proportion. And so that's the variable notation that you're going to use anytime you want to discuss the population proportion. So the point estimate, it's just that estimator for that population proportion that we're going to use. And the reason that we use it is because it's the most consistent of any of the other unbiased estimators. So what does that really mean? The best estimate of the population proportion, rho, well, this is just going to be the sample proportion that we're going to call p hat. So why do we use p hat? Basically, the long-run average of your p hat, or your sample proportion, is really the true value of your population proportion. Meaning, if you took a bunch of random samples, the average is going to be rho, or the population proportion. Some general notations that you're going to need to know. When talking about a population, P is the probability of success and Q is the probability of failure. When you are working with a sample, we'll refer to those successes and failures as P hat and Q hat. Additionally, when you're given a sample, P hat can be found by the fraction x divided by n, where n is the number in the sample and x is the number of successes you are looking for. Q hat can still be found by 1 minus P hat. Your confidence interval estimate. Because you're dealing with a proportion, you do not include units. Just as we've done before, when you have a fraction, a decimal, or a percent, you never have units when you are dealing with those numbers, so you're not going to have units when you're dealing with a confidence interval estimate. You're also going to be rounding all of your values in these confidence interval estimates to 3 decimals unless you're told otherwise. Now you have 2 ways that you're going to be looking at your estimate. The first is written as an inequality. Your value for rho, or the population proportion, is going to be in between 2 values. These values are going to be called your confidence interval limits, or your lower and upper bounds. Now you're not going to need to be able to actually calculate these values, but these values are going to be the combination of 2 numbers that you're going to find using your calculator. So the lower limit is going to be the difference between your p hat minus what we're going to call your margin of error, and your upper limit is going to be the sum of your p hat plus your margin of error. And I'm going to show you your margin of error in a few minutes. But it's going to be the value that's going to be combined here. Now this is called inequality notation because you're going to be writing your population proportion as an inequality in between these 2 values. Interval notation is written slightly different, and it's going to be written with these open brackets. So on the left-hand side, you have this open parenthesis, and then the p hat minus e. That left-hand side is your lower limit. The comma represents all of the values for your population proportion in between that and your upper limit, which ends at p hat plus e, and then we close our parenthesis. Remember that with inequality notation, that is different from interval notation. Interval notation has these little parentheses that start and stop your lower and upper limits, while inequality notation does not. Now, there are several ways to be able to find the margin of error using formulas. What you're going to do is that when you are using your calculator feature that I'm going to show you, the calculator is actually going to do some really cool things for you, and it's going to calculate the margin of error for you. And when those things happen, you are not going to use the nasty formula. So when you're given a simple random sample and you're using that to estimate the population proportion, you're going to use a specific notation. you are always going to use an uppercase E when representing the margin of error. Now, in some reference materials and even in some homework materials like in MyOpenMath or in any other places you see like in AI, sometimes they'll use an uppercase ME, and you're not going to be using that notation. You will only be using an uppercase E to represent margin of error. Now, when you're using a calculator feature to be able to find your confidence interval estimate, not only is the calculator going to give you an upper limit, but it's also going to calculate that p-hat for you. And because it's doing all of that, you're going to use those two values and write the difference between the two and do your calculations. Since you're working with a population proportion and everything is rounded to 3 decimals, you're going to round your upper limit to 3 decimals, and you're going to round your population parameter here, p-hat from the sample, to 3 decimals. So your margin of error will also be rounded to 3 decimals. And again, you're not going to include units. Occasionally, you're going to be asked to only find the margin of error with a sample that you're given. And sometimes you are not given enough information to even be able to use the calculator feature to do anything else. When that's done for you, and when that's what's being asked, then you're going to have a formula that you're going to be able to use. Now, this formula is a formula that you can always use to calculate the margin of error, but for us, you'll only use this when you're not using the calculator feature to do other work. You'll still start with E equals because that is your margin of error notation. But it's this gnarly looking algebraic formula that starts with Z sub alpha over 2, which means you have extra work you have to do because you have to go find the critical value using all of the algebra work that goes along with that. Then you're going to multiply times the square root of p hat times q hat and divide by n. So this formula, while it is completely useful and doable, has a lot of algebra that goes along with it. So you will only use this when you have to find just the margin of error, where no calculator feature is allowed or required.